Hey everyone, in today's video we're going to be going over the top 5 hardest SAT math questions ever made. We've got 2 geometry and 3 algebra questions for you, and we're just going to jump right into it. So we've got problem number 1, which is a circles problem. Those are notoriously hard in the SAT, and this is just the easiest of the 5 questions that we are going to be working towards. So, in the figure below, 3 identical circles of radius 8 with centers O, P, and Q are tangent to each other. What is the area of the shaded region? So we've got a shaded region right here, bound by the circles. So take a minute and see if you can solve this by yourself. Alright, so here's how I'm going to solve it. So we know that we have a point of tangency here, a point of tangency here, and a point of tangency here. Alright, knowing this, we can draw a line from each radius to the point of tangency. And we know that the radius is equal to 8 because of the problem. Alright, so this is 8. This is from here to here is 8. From here to here is 8. All right. From here to here is 8. This is 8. This is 8. And this is 8. And you'll notice we've created an equilateral triangle. And this triangle encompasses the entire shaded region. All right. But it adds some black space here. Okay. So the first thing we're going to do is we're going to try to find the area of this triangle. Now we can use the Pythagorean theorem, because we know that this side length here is a total of 16 and this one's 8. So we have a squared plus b squared is equal to c squared. Okay, let's call this side a. That means we have 64, which is 8 squared, plus b squared is equal to, so this is 16 squared, which is 256. 256, alright? That means that we have b squared is equal to, if I subtract 64 from both sides, 192. Alright, so if we wanted to find b is equal to the square root of 192. Now that we know that, right, we can just find the area of the triangle, because we know that this side is the square root of 192. Now the formula for the area of a triangle will be given to you on the SAT is 1/2 times base times height. All right, so we know our height here is the square root of 192. Our base is technically 16, right? But we can just apply this dividing by 2 rule. So we can say our base is, or the total of this term is just going to be 8. So 8 times the square root of 192. Alright, so now we found the area of the triangle. Now that means we found the area of the shaded region, but we need to subtract all these black areas, right? So all these black areas here. Now we know that this is going to be 60 degrees, right? And why do we know this? Because we have 180 degrees in a triangle, right? And if this is an equilateral triangle, which we've seen here, all the sides at the same length, right? They're all 16. That means that they all have the same angle. So that means that we would have to divide this by 3 because there's 3 angles, which is going to be 60 degrees. All equilateral triangles have an angle measure. Each angle in an equilateral triangle is 60 degrees. Okay, let's move on. So since we have 60 degrees, right, and we have 360 degrees in an entire circle, that means that 60 over 360, right? That means we have 1/6 of our full circle represented here, right? So this portion here, this chunk of the circle, this is 1/6. And we know that the area of a circle, is equal to pi r squared. In this case, it would be pi times 8 squared, which is equal to 64 pi. So to find the area of this region, right, we can just multiply the 64 pi by 1/6. But the thing is, we have 3 of them, and we know that they're all the same because they're all the same portion, right? They're all the same angle, and these are all congruent circles, right? Because they all have the same radius, right? So that means we have 3 of these portions. So let's actually just multiply this by 3, right? So we multiply by 3 and we divide by 6 because this is 1/6, but there's 3 of them. All right, if that makes sense. So if we took all these, and then we'd have another one here and another one here, and that would just be half of a circle, right? So this would just be equal to 64 pi over 2, right? Because 3/6 is equal to 1 over 2. And then this is equal to 32 pi. We just divide out the 2 here, put it up there, right? So that means that we know that the area of all this black space is 32 pi. So if we subtract that from our original length, right, from our original triangle, right, we should have our answer. And we know that that original triangle was 8 times the square root of 192. So that means that our answer should be 8 square root 192 minus 32 pi. But we're not finished yet because that's not one of our answer choices. All right. a problem like this is not going to be one of those open response questions because there's a way to simplify, and you may have to simplify a radical many times on your SAT test. So the way we're going to do this, we're going to try to pull square numbers out of this 192. So it is divisible by 16. So that means we can do 16, then the other factor would be 12, right? 192 is equal to 16 times 12. All right. We can split 12 and do square root 4 times square root 3. And therefore, we get 8 times the square root of 16 times the square root of 4 times the square root of 3, which is equal to 8 times 4 times 2 times square root 3. We multiply these together. And what do we get? We get 8 times 8, which is 64 times square root 3. Therefore, we can move this up here. We're going to get 64 square root 3 minus 32 pi. That is option C. Alright, and here is question number 2. We have a linear equations and reading comprehension question. Alright, so we have the participants who are on a certain community service club come from all 4 grade levels in Smithville High School. There are equal numbers of sophomores and juniors. The number of seniors is 20, more than twice the number of sophomores and juniors combined, and there are 20 freshmen. If the number of sophomores, juniors, and seniors combined accounts for just 80% of the club's participants, how many seniors are there in the club? So firstly, in an SAT problem like this, they often give you information that's helpful in every single sentence. These are often some pretty long problems, but it's important to read them all the way through. For instance, the first sentence here tells us explicitly that there have to be non-zero levels of every single grade level. Equal numbers of sophomores and juniors. So we can just write this out right now as a math thing. So sophomores is equal to juniors. I'm not going to use variables. I'm not going to use traditional variables because seniors and sophomores might get confused when you're working quickly on an SAT exam. That's an easy mistake to make, and of course a catastrophic one, especially one like this where we have a student-produced response question. Okay, now the number of seniors is 20 more than twice the number of sophomores and juniors, and we know that sophomores is equal to juniors, right? So if we have seniors, so seniors is equal to 20 more than twice sophomores plus juniors. This is equal to, because sophomores equals juniors, this is equal to 20 plus 2 times sophomores. We know that there are 20 freshmen. That's explicitly given to us. If the number of all of these grades, these 3 grades here, sophomores, juniors, and seniors, combined accounts for 80% of the club's participants, how many seniors are there? Well, if this is 80%, right, if soph plus juniors plus seniors equals 80%, right? And there are 20 freshmen. That means the freshmen are 20%, which is equal to 20. Therefore, each person is 1%. All right, that makes it a lot simpler for us here. So we can just think of people as percentages, right? But that means that sophomores plus juniors plus seniors is equal to 80 total people, right? So that means that this here, this 20 plus 2 plus sophomores plus juniors, right, and the seniors here, right, these two equations must total add up to, or when we find the number of seniors, right, when we find the number of seniors, we add the sophomores and the juniors, that's equal to 80, right? So sorry if this is a little bit unclear because it is definitely probably one of the most complicated problems algebraically, or a word problem that you can see on the SAT. Right. So we know that the sophomores and the juniors and the seniors is going to add up to 80. And we know that the number of seniors is equal to 20 plus 2 times the number of sophomores plus the number of juniors. Right? What that means is that if these two things are kind of set equal here, right, this will be equal to 40. This will be equal to 40. Right? So let's just set that equal to 40. Let's set this equal to 40. So 40 is equal to 20 plus 2 times the sophomores, right? That means we get 20 is equal to 2 soph. Therefore, 10 is equal to sophomores, right? And that means that 10 is also equal to juniors because juniors is equal to sophomores. So now we know that the sophomores and juniors make up 20. Therefore, the seniors, right, the seniors are equal to 60. Because these total are 80. We subtract our seniors, which are, or we subtract these guys, those are 20. So we get that there should be 60 seniors. 60 seniors. All right, and well, now let's see if this checks out, right? And you could always use Desmos, but we're going to try to solve these like completely algebraically here. Okay, let's just check this out here. So number of seniors is 20 more than twice the number of sophomores and freshmen. Is this true? Well, this number of sophomores and number of freshmen, and the number of juniors. The number of sophomores and the number of juniors is going to add up to 20. Multiply that by 2, we get 40. And 60 is indeed 20 more than 40. So our math checks out. There are 60 seniors. All right, we're back with the third question here. So this is an algebraic manipulation question. I would say this is probably a little bit easier for most people, but for some people, this is a type of question that could definitely pose a challenge. So for integers a and b, where a is greater than 0 and b is greater than or equal to 0, let the operation square be defined as a squared b is equal to a to the power of b over a, which the following could be the value of a squared b. So when we see a problem like this, the first thing to take a look at is definitely the answer choices, all right? So which of these could be true? So it's 1, 2, 2 and 3, or 1 and 3, all right? So 3 cannot just be true on its own, okay? Something else has to be true as well. But the first one we're going to take a look at is 2, because 2 we can eliminate this, and 1 we can eliminate 2 as well. We can eliminate 2 options as well. But if we do that, it's also going to be a little bit more complicated because this is obviously more complex than proving this one. Take a minute, see if you can solve this one. Alrighty, so we're going to take a look at number 2 first, as I said. So a squared b, right, question mark, is equal to ab over a. Can this be true? This is equal to 0. Alright, well, let's think about this. For something to be equal to 0, right, we need to have the top be equal to 0, right? It has to be 0 over some number x or y or whatever, right? But if we have a positive integer and we raise it to any positive or zero exponent, can we ever get 0? No. Because when we have something like a to the 0, this is always equal to 1. Right? If we have a to the b that's a positive number, any positive b, it's going to be a positive number. Right? Because we know that a is going to be positive. So it's not possible for this to ever be 0. Alright, and this is something you really need to know your exponent properties for. Take a look at the next simplest one here, right? We can eliminate one more option here. If it's 1 and 3 or just 1, if this is an incorrect statement, can this ever be equal to 1? Well, as we mentioned here, if we have a to the 0 is equal to 1, right? And sorry, I kind of covered this up, but b can be greater than or equal to 0, right? If a to the 0 is equal to 1, if b equals 0 and a is 1, then we'd have 1 over 1 to the 0, which is equal to 1 over 1, which is equal to 1. So 3 can be true. All right, so 3 can be true. So right away we can think, okay, it's probably just D, right? It's probably just D right here. But let's just take a little deeper dive and see if we can prove 1 to be correct. So a to the b times a to the negative 1. Now again, what we're going to do is we're going to look at our exponent properties. Now when we have a to the x times a to the y, this is equal to a to the x plus y. In this case, we have a to the b times a to the negative 1, so this would be a to the b minus 1. Okay, now we can see here we have another exponent property. A to the b over a, right? What this is equal to, and we have a to the x over a to the y, this is equal to the a to the x minus y. And we know that a is equal to a to the 1, right? So that means that here, what we really have is very simple. It's a to the b minus 1. And these two things are the same thing. Therefore, we can prove that number 1 and number 3 are correct. Therefore, the answer is D. All right, we are on our second to last problem. Make sure to stick around for that last question. It is extremely difficult. In fact, there was a similar question on a past SAT for that question that actually had no correct answer choices, known to be the only SAT problem ever to be a completely invalid question. So it was so hard that even the College Board got it wrong. All right, let's move on to this question here. This is one of my favorite questions. So in the figure below, OPQR is a square, PS is the arc of a circle with center O. If the length of the arc PS is pi, the area of the shaded sector is what fraction of the area of OPQR? Take a second, see if you can solve this up. All right, so we know that the length of arc PS is pi. We know that this is pi. We also know that this is 30 degrees. All right, what is 30 degrees equal to? 30 degrees is equal to pi over 6 radians. Pi over 6 radians. So what does that mean for us here? All right. So if this is pi, right, And then what that means, we have arc length, which is s, is equal to r times theta, the radius times the degrees, right? The radians. So that means we have s, which is equal to pi, is equal to r times pi over 6. By the way, this is a formula you should know. It is not on your reference table. This is a formula you should know by heart. Anyway, so we're going to multiply both sides by pi over 6. We're going to get 6 is equal to r. All right, and what that means is that r is the radius, r is equal to 6. We know that this is part of a circle here. This is kind of a chunk, an arc of a circle. So it means that the radius is 6 here. This is 6. That means that this is also 6. This is also 6. That means the side lengths of the square are also 6. All right. Now what that means is that this square is equal to 36. Right? 6 by 6. The total area of the square is 36. But what is this, right? What is this here? So we know that the area of a circle from a previous question in this video is equal to pi r squared, which means it is equal to 36 pi in this case because our radius is 6. All right, but we are only finding this fraction. All right, how much is 30 degrees of 360 total degrees? 30 degrees over 360 total degrees is 1, right? 1 over what? See if you can do this in your head real quick. It's going to be 1 over 12. So we can divide this by 12, right? Because we are finding only a portion of the area, only 1/12 of the area. It's equal to 3 pi. So that means our answer, what is a shaded region? All right, and I'm sorry for only using one color on this problem, is 3 pi over 36. What is 3 pi over 36 equal to? Well, it's going to be pi over 12, which is our answer, C. Again, that's one of my favorite problems in this entire video. One of my favorite SAT problems of all time. I think it requires a lot of problem solving, a lot of manipulation of formulas. Great problem. All right, this is what we have all been waiting for. The hardest SAT problem ever created. A small circle A is rolled around the circumference. Let's write this down. We know this information from our answer sheet. Circumference equal to 2 pi r of a larger circle B as shown in the figure. Circle A starts here and ends here. It makes 2 complete rotations from here to here. Okay, if the ratio of the areas of A to B is 1 to 25, what is the value of x in degrees as we see by this degree symbol here? All right, let's break this down. How can we figure out this at all, right? Where do we start? Take a second, see if you can solve this for yourself. All right, well, we're going to start with the radii, okay? If we want the area to increase by a factor of 25, we want the radius to increase by a factor of 5. Why? Because that factor is going to be squared to get us our new radius, right? And of course, the square root of 25 is just 5. And we can see this here. Let's say we call A's radius 1 and B's radius 5, right? We would have A is equal to pi times 1 squared, which is equal to pi. And then we would have B is equal to pi times 5 squared, which is equal to 25 pi, right? This is clearly a ratio of 1 to 25. All right, so let's just keep these ratios constant. We'll have 1 here, and we'll have 5 here, and I'll show you why it doesn't really matter which numbers we choose as long as they're a factor of 5 apart in the radii, but we'll do that at the end. Anyhow, what we want to do is we want to see how far this one's going to travel and what fraction of that is the entire circle. So to do that, we're going to use the circumference. So the circumference of A is equal to 2 pi times r, which is 1, and the circumference of B is equal to 2 pi times the radius, which is 5. Okay, this is 10 pi, this is 2 pi. But we're going around twice. So it's traveling this distance, right? It's traveling this distance to get to here, and then it's doing it again. So the total distance traveled is 4 pi units. We don't really know what these units are, we just know they're units. So it travels 4 pi units. And the circumference of this is 10 pi units. Right? And we don't need to really continue writing units, so I'm gonna kind of cross them out now. Okay? We know that the fraction of the circle here then is 4 pi over 10 pi, right? Because this is the total circumference, and this is the amount that we went around the circumference. The pi's cancel, we get 2/5. So 2/5 of 360 degrees, right? Because our degrees are always, you always need to have a ratio of 360 degrees in a full triangle. So we went around 2/5. how many degrees would that be? All right. So we need this bottom number here to be 360. So let's say 360 divided by 5, right, to find our scale factor. Okay, we can put this in here, so we get 35, we have 10. So our scale factor here is 72. So let's multiply the bottom and the top of this fraction by 72. And we're going to get 144 over 360. So let's put this in degrees. All right, this is 144 degrees of 360 degrees, which is our full circle. Therefore, x is equal to 144 degrees. And now I'm going to show you why it doesn't matter what our radius is, regardless of the fact that it is a ratio of 1 to 5. All right, let's say that we're just going to use a variable here. This is going to be r. This is going to be 5r. All right. What we're going to get then is we're going to get 2 pi r. And over here, we're going to get 10 pi r. And again, when we make that ratio here, right, and we have to multiply that as 2 still. All right, we're gonna still get 4 pi r over 10 pi r. And these guys are all just going to cancel. We're still going to get that 2/5 number. So it doesn't really matter what the radii of these circles actually is, but it just matters that they're, a factor of 5 apart in the radii. Okay, those were the 5 hardest SAT problems ever created. If you think we missed one, put it down in the comments below. Be sure to check us out for more SAT prep videos.